So in this video we are going to discuss transportation model, and we'll be looking at a special type of the model which is called as a balanced transportation model. So the main characteristics of the transportation model are that in these models a product is transported from number of sources to a number of destinations, and the objective is to do this at the minimum possible cost. And each source it is able to supply a fixed number of units of the product, and each destination has a fixed demand of that product. The linear programming model that is used for such models, it has constraints for supply at each source and for the demand at each destinations. So in the balanced transportation model, the supply is equal to the demand. So this is the main characteristic of the balanced transportation models. So when we have a balanced transportation model, all the constraints that we write, they are written in equalities. That is, we write them by using equalities in such transportation models. So let's have a look at an example to understand these concepts. So we have an example of a company which is a electronics company, and it has ramped up the production of its high performance laptops, and these laptops are manufactured at the following sites. The first is in China, second is in Poland, and the third is in Mexico. Each production site has some capacity. For instance, China has a capacity of 500 units, Poland has capacity of 600 units, and Mexico has capacity of 400 units. These laptops, these are to be distributed to the regional fulfillment centers. These basically the demand centers, which are in New York, which has a demand of 300 units, and Dubai, that is a demand of 700 units, and Cape Town, that has a demand of 500 units. The shipping is done using the air cargo and the ocean freight, depending upon the distance and urgency. So the estimated shipping cost per unit in USD from each source to each destination, it is given in this table below. So as you can see in this table, that from China to New York, the shipping cost is 6 USD per unit, and from China to Dubai it's $8, and to Cape Town it's $10. And similarly, we have the cost of transporting from Poland to New York, Dubai, and Cape Town, and from Mexico to the three demand centers. So the objective is to minimize the total transportation cost while satisfying all demands. So this type of problem we can depict it by using a diagram where these nodes on the left hand side, they show the supply nodes, and there are three supply nodes. First is China, second is Poland, and then we have Mexico. The supply quantity available at each node is also mentioned here. For instance, for China it's 500 units, for Poland 600, and for Mexico it is 400. And on the right hand side, we have demand centers at New York, Dubai, and Cape Town, and the demands are also written on the right hand side. So if you sum up the supply, it is equal to 1500, and if you sum up the demand, it is also 1500. So since the demand is equal to supply, so this is called as a balanced transportation model. So from each supply node, we can draw a arrow, let's say from China to New York, and similarly we can draw an arrow from China to Dubai and China to Cape Town. So here the quantity which is shipped from China to New York, it is represented as X1A. That is quantity that is being shipped from node 1 to node A, from China to USA to New York, and we have denoted it as X1A, and the cost per unit transportation is 6 USD. In a similar way, we can draw a arrow from China to Dubai showing the quantity, and it will be represented as X1B, and the cost will be as shown in the table. It was 8 USD. And then we have from China to Cape Town X1C and the 10 USD. In a similar fashion, we can draw the arrows from Poland to New York, Dubai, and Cape Town, and then from Mexico to New York, Dubai, and Cape Town. And we can represent the quantities from Poland to New York as X2A, from Poland to Dubai as X2B, and from Poland to Cape Town as X2C. And on these arrows, we will also mention the cost that is incurred when we are transporting the laptops from Poland to New York, Poland to Dubai, and Poland to Cape Town, as you can see on your screens. So a similar procedure is done for the Mexico as well. So these diagrams, they come and they are very handy when you're writing the objective function. So based on this information, we can write the objective function, and the way to write it is as minimize z is for our objective function, and this will be equal to 6 the cost from China to New York, and then the quantity 6x1a plus 8x1b plus 10x1c plus 7x2a plus 5x2b plus 9x3a. And then we have 8x the cost from transporting laptops from Mexico to New York. This is 8 USD per unit into x3a plus 6x3b and plus 7x3c. So this is our objective function. Now the constraints for supply. So first we look at the supply constraint. We know that the quantity that can be shipped from China is 500 units, and the quantity that can be shipped from China is represented by X1A plus X1B plus X1C. And since it's a balanced transportation problem, we will use equality sign here. This should be equal to 500. This is because we are saying that all the quantity from the China must be shipped to the destinations, because we have to fulfill the demand, and this can only be done by forcing all the quantity available at the source node to move towards the destination node. So in a similar way, we can write an equation for Poland, and that would be x2a plus x2b plus x2c. So I just noticed that there is some mistake here. This is not 3a, this is x2 2c, sorry, x2c. This is x2c, and this is equal to 600. And then we have the supply constraint for Mexico, and it will be, I'll just write it here, x3a plus the quantity shipped from Mexico to Dubai, x3b plus x3c, it must be equal to 400. So important thing is equality must be mentioned here. And then we will so we have like three constraints, one, two, and three constraints for the supply, and then we will write the constraints for the demand as well. So the demand must be fulfilled, and it's a balanced problem. So the quantity that can be received at A is from 1 x1a, and from 2 x2a plus x3a, that is quantity from Mexico to New York, and that must be equal to 300. And in a similar way, we can write for Dubai, it will be x1b plus x2b plus x3b, this is equal to 700. And for Dubai, it will be x1c plus x2c plus x3c, this must be equal to 500. So we have three constraints for supply and three for demand. So total six constraint. And finally, we also have a non-negativity constraint that says xij is greater than equal to 0, where I is representing the supply, that is 1 2 3, and j is representing the demand, that is a b c. So that's the complete mathematical model for this balanced transportation problem. This is also summarized in the next slide. So if we write it formally, then we must first define the decision variables. So x1a, x1b, x1c, or xij, where I represents the supply and j represents the demand, and they must be greater than equal to 0. So these are the decision variables. Then comes the second part, that is the objective function, and as discussed in my previous videos, that objective function must be written in terms of decision variables. So 6x1a, 8x1b, 10x1c, and so on and so forth, as discussed in the previous slide. And then we have supply constraints, and then we have demand constraint. Important thing to understand here is, in the balanced transportation model, we always use equalities. So this is the complete mathematical model for the balanced transportation problem. In the next video, we will see how we can solve this model on the Excel. Thank you.